Imagine living in a reality where there are infinite versions of you, each living out a different decision you've ever made. Sounds like science fiction? Welcome to the Multiverse Theory. This tantalizing concept, that we might be just one of countless universes, has been tantalizing scientists and sci-fi fans alike for decades. The seeds of this theory were planted by theoretical physicists who dared to venture beyond the boundaries of our observable universe. They postulated that our universe could be just one among an infinite number of universes, each with its own laws of physics. This idea, born out of complex mathematical equations and high-level theoretical physics, has evolved into a topic of intense debate and speculation. So, what if we're not alone, but part of a vast multiverse? What would that mean for us and our understanding of reality? Sounds intriguing? Let's dive in and explore this fascinating theory. What if I told you that our universe might just be one of an infinite number of universes? This is the essence of the multiverse theory. Now, it sounds like a concept straight out of a science fiction novel, doesn't it? But in the realm of theoretical physics, it's a proposition that's taken quite seriously. The multiverse theory postulates that our universe, the one we perceive with its galaxies, stars, planets, and everything else, is not the only universe. Instead, it suggests that there might be a multitude of universes, each existing in parallel and perhaps even with its own set of physical laws and constants. But how could such a multiverse come into existence? Well, there are several models that attempt to explain this. One of the most well-known is the many worlds interpretation. This model, rooted in quantum mechanics, proposes that every time a quantum event occurs, like the decay of a radioactive atom, the universe splits into multiple versions. Each version represents a different possible outcome of that event. Then there's the inflationary multiverse model. This model suggests that our universe is just one bubble within a much larger cosmic landscape. The idea is that shortly after the Big Bang, space underwent a rapid exponential expansion, a process known as inflation. As inflation proceeded, it could have created countless separate bubbles, each one forming a distinct universe with its own physical properties. These models suggest a cosmos teeming with parallel realities. But remember, as fascinating as these ideas are, they are still just theories. The existence of a multiverse is far from proven. But as we continue to explore the mysteries of the cosmos, who knows what we might discover? The universe, or should I say, the multiverse, is a truly remarkable place. Quantum mechanics, the science of the very small, has a big say in the multiverse theory. This intriguing branch of physics, dealing with particles at the atomic and subatomic level, introduces some mind-bending concepts that challenge our everyday understanding of reality. One of these concepts is the idea of superposition. In the quantum world, particles don't have definitive states until they're measured. Before measurement, they exist in all possible states simultaneously. This is the principle that allows for Schrödinger's infamous cat to be both alive and dead until we take a peek. Now, let's introduce the many worlds interpretation, an explanation of quantum mechanics that avoids the measurement problem. According to this interpretation, there's no wave function collapse when we measure a particle. Instead, all possible outcomes of the measurement occur in separate, parallel universes. Picture this: a cosmic choose-your-own-adventure, where each choice spawns a new universe. In one universe, you chose coffee over tea this morning. In another, you went for a jog instead of hitting snooze. And in yet another, dinosaurs never went extinct. This interpretation suggests that quantum events, which involve particles interacting and changing states, are constantly creating new universes. Every time a quantum event happens, the universe splits into multiple parallel universes. Each universe represents a different possible outcome of the event. Of course, this is an interpretation of quantum mechanics, and interpretations are ways to understand what the math is telling us. They are not necessarily literal truths about the nature of reality. But if the many worlds interpretation is on the mark, then the multiverse is a vibrant, ever-branching tree of realities. So every quantum event could be creating countless universes. As mind-boggling as the multiverse theory is, there's some scientific evidence that suggests it might be true. A significant part of this evidence comes from the field of quantum mechanics. Here, particles behave in ways that are, frankly, downright mysterious. They can exist in multiple places at the same time, and their properties only become defined when they're observed. These quantum oddities lend support to the many worlds interpretation, a view that each quantum event splits the universe into different versions, each experiencing a different outcome. But quantum mechanics isn't the only place we find hints of a multiverse. Let's turn our gaze to the cosmos. The cosmic microwave background radiation, or CMBR, is a faint glow of light that fills the universe, the afterglow of the Big Bang. Fluctuations or variations in this radiation are thought to be influenced by quantum effects at the birth of our universe. Some scientists suggest these variations could also be imprints left by other universes bumping into ours, a sort of cosmic bruising. Beyond this, the theory of cosmic inflation, which explains the rapid expansion of the universe following the Big Bang, also points towards a multiverse. If inflation is an ongoing process happening in different regions of space, it could lead to an endless creation of bubble universes, each with its own laws of physics. In addition to these, there are experiments being conducted to search for evidence of a multiverse, like those at the Large Hadron Collider. While no definitive proof has yet been found, the search continues. So, while the idea of a multiverse might seem like the stuff of science fiction, the scientific underpinnings are very real. We're beginning to gather pieces of a puzzle that could eventually reveal a picture of reality far grander and more complex than we ever imagined. This evidence, while indirect, tantalizes us with the possibility of a multiverse. A multiverse could turn our understanding of cosmology on its head. This statement might sound dramatic, but it's not an exaggeration. The existence of multiple universes would significantly impact our comprehension of the cosmos, and the implications are both intriguing and mind-boggling. Let's start with the basics. Cosmology, as we currently understand it, is largely based on the observation of our universe. We study its history, structure, and evolution to learn about its origins and eventual fate. But what if our universe is just one among an infinite number? This fundamental shift in perspective would require us to rethink many of our established theories and models. In a multiverse, each universe could have its own set of physical properties. The laws of physics as we know them might not apply everywhere. For instance, the speed of light, the gravitational constant, or the charge of an electron could vary from one universe to another. This diversity of universes, each with its own unique characteristics, is a concept we refer to as the cosmic landscape. The existence of a cosmic landscape would also have profound implications for the fine-tuning problem. This problem arises from the observation that our universe appears to be finely tuned for the existence of life. If certain fundamental constants were even slightly different, life as we know it would not be possible. In a multiverse, however, there could be a vast number of universes where conditions are not right for life, and only a small fraction where they are. We just happen to exist in one of the latter. Furthermore, the multiverse theory could shed new light on the origins of our universe. Some models suggest that our universe could have been born out of a larger multiverse, perhaps through a process similar to black hole formation. In conclusion, the existence of a multiverse could fundamentally change our understanding of cosmology. It would present new challenges, but also open up exciting new avenues for exploration and discovery. The multiverse theory could redefine our understanding of the cosmos. While the multiverse theory is compelling, it's not without its critics. As we delve deeper into the cosmos, we find ourselves in a labyrinth of questions, theories, and paradoxes. Among them, the multiverse theory is a prominent one, but it has its fair share of criticisms and challenges. Some experts argue that the multiverse theory is more of a philosophical concept than a scientific one. They contend that because we cannot directly observe or test for other universes, the theory falls outside the realm of empirical science. It's a compelling point of view that reminds us of the importance of testability and falsifiability in scientific theories. Others question the mathematical models that underpin the multiverse theory. They suggest that these models are based on assumptions that may not hold up under closer scrutiny. These critics argue that we should be cautious about extrapolating beyond what we can directly observe and measure. There are also those who propose alternative explanations for the phenomena that the multiverse theory attempts to explain. For instance, some argue that the apparent fine-tuning of the universe for life could be explained by a natural process yet to be discovered, rather than the existence of a multitude of universes with varying physical properties. Moreover, there are ongoing debates about interpretations of quantum mechanics. While the many worlds interpretation suggests a multiverse, other interpretations do not. These alternative interpretations offer different perspectives on the strange world of quantum mechanics, without invoking the existence of multiple universes. Despite these criticisms and challenges, proponents of the multiverse theory argue that it provides a compelling framework for understanding the cosmos. They suggest that while we may not be able to directly observe other universes, we might find indirect evidence or theoretical support for their existence. In the end, the multiverse theory remains a tantalizing idea that pushes the boundaries of our understanding. It challenges us to consider possibilities beyond our observable universe and sparks fascinating debates within the scientific community. The multiverse theory remains a hotly debated topic in the scientific community. The multiverse theory doesn't just challenge our scientific understanding, it also has profound philosophical implications. It invites us to question the very nature of reality. What do we mean when we say something is real? Is it something we can perceive, measure, or interact with? Or does the reality extend far beyond our limited perceptions? In the context of the multiverse, reality becomes a vast, complex tapestry of countless universes, each as real as the next, yet potentially inaccessible and unknowable to us. This brings us to the concept of determinism. Traditionally, determinism suggests that every event or state of affairs, including every human decision and action, is the inevitable and necessary consequence of antecedent states of affairs. But in a multiverse, where every possibility is played out across an infinite number of universes, does determinism still hold? Or do we instead have a kind of cosmic indeterminism, where every possible outcome of every event exists somewhere in the multiverse? And what of free will? In a deterministic universe, free will is often seen as an illusion. After all, if everything is the result of preceding causes, then our choices are predetermined, and free will becomes a comforting fiction. But if we live in a multiverse where all possibilities are actualized, then every choice we make could be seen as creating a branch in the universal tree, leading to a new universe where that choice plays out. This suggests a kind of radical freedom where our choices have a cosmic significance, birthing new universes with every decision. These are just some of the philosophical implications of the multiverse theory. And while they may not have definitive answers, they serve as a reminder that the quest for understanding our universe, or perhaps multiverse, is as much a philosophical journey as it is a scientific one. The multiverse theory truly blurs the line between science and philosophy. The multiverse theory is a mind-bending hypothesis that challenges our understanding of reality. This journey into the complexities of the multiverse and its implications has been nothing short of fascinating. From the intriguing concept of parallel realities that coexist within the multiverse, to the idea that each universe could have its own set of physical laws and constants, the multiverse theory pushes the boundaries of our imagination. We delved into the connection between this theory and the enigmatic field of quantum mechanics, particularly the many worlds interpretation. We explored the possibility of quantum events leading to the creation of multiple branching universes. From there, we ventured into the concept of the inflationary multiverse, where rapid cosmic inflation could lead to the formation of distinct, bubble universes, each with its unique properties. The journey did not stop there. We examined the observational evidence and experiments that hint at the possibility of a multiverse. We discussed how phenomena like cosmic microwave background radiation might provide indirect support for this mind-boggling theory. Our understanding of cosmology could be drastically reshaped if the multiverse theory holds true. We explored the potential for a diverse array of universes with different physical properties, and the implications that this diversity could have on our understanding of life and its conditions. We also took a philosophical detour, discussing the nature of reality, determinism, and free will in a multiversal context. We delved into the anthropic principle, string theory, and the idea of extra dimensions, each providing a different lens to view the multiverse hypothesis. Throughout this discussion, we also acknowledged the criticisms and challenges to the multiverse theory. We explored alternative explanations and ongoing debates within the scientific community, which remind us that this theory, while compelling, is far from universally accepted. Whether fact or fiction, the multiverse theory gives us a fascinating new perspective on our place in the cosmos. As we continue to probe the mysteries of the universe, or should we say multiverse, let's remain open to new possibilities, to new understanding, and to the endless wonder that science brings to our lives.